Hello everyone and welcome aboard the Data AI Express. Today we are kicking off a brand new essential series on topic that forms the backbone of the modern digital world, data architecture. You have heard the phrases data is the new oil, data is the new electricity. But what does that really mean? How do we protect this invaluable asset? Most importantly, how can we leverage it to understand our past, analyze our present, and accurately predict our future with the data that we have in hand? This is not just a question for massive corporations. It's a crucial for businesses of every sizes. To unlock the true power of data, you need a rock solid foundation, and that foundation is called data architecture. So let's learn about the data architecture together. In our YouTube Data and AI Express channel, we are looking out an ultimate guides on each topics data, AI, generative AI, Snowflake Databricks. In the same ultimate series, now we are looking out data architecture. Let's start with explore the data architecture journey. We are going to cover a complete guide for data architecture principles and patterns. It covers the available data load, data modeling methods from basic to advanced, when to choose what method, futures trends to get yourself prepared. I'm sure it's going to be a definitely a go-to guide for the data introduce on data design topics. What is data architecture? Data architecture is a structured management of how data is collected, stored, integrated, governed, and consumed for business purposes. It evolved from siloed, fragmented systems to modern approaches like data lakes, data mesh, data fabric, and lakehouses. It's all driven by the need for agility and unified analytics. In fact, data architecture is a subset of enterprise architecture. Enterprise architecture has broader categories like business architecture, technical architecture, application architecture, and data architecture is one of the pillar for the enterprise architecture. Think of it as a master blueprint for how an organization manages its entire data landscape. It is a formal set of models, policies, standards that govern how a data is collected, stored, and used across the company. Imagine a company with different departments finance, sales, HR, marketing. Each one generates its own unique data. How do you bring all of that disparate information together? How do you structure it so that you can easily find what you need and uncover the powerful insights? A well designed architecture is the answer. Without it, building a data driven business is impossible. That's why this is so fundamentally important. In more formal terms, data architecture is the practice of designing, deploying, and managing how data flows through organization. It defines every step of journey from the collection, storages to integration and consumption. And what's the ultimate goal? To ensure that your data is always accurate, complete, secure, and most importantly, available to the right people at the right time. Now, let's explore the core principle that define a great data architecture. Any robust architecture must be built on these 10 pillars. It needs clarity and operational excellence. It must be reliable, scalable, flexible, and above all, secure. And it doesn't stop there. It also has to be a cost efficient, deliver high performance, and enable business agility and adaptability. Data architecture has come a long way. Back in the 1960s, everything was manual, think paper files and punch cards. The 70s gave us relational databases, followed by the OLTP system in 80s. The 90s marked the birth of modern data warehouse. Then came the 2K and the big data explosion, which led to the rise of cloud computing and data lakes in the 2010s. And that brings us today, 2020, the undisputed era of AI. Let's look at the core concepts and principles of the data architecture. The 5 Vs: volume, variety, velocity, veracity, and value. I repeat, 5 Vs: the volume of data, variety, the velocity, veracity, and finally the value it provides. For the distributed system, The power of big data will rely on the CAP theorem, which states you can only ever have two of the following three guarantees: consistency, availability, or partition tolerance. At any point of time, any two only you can able to match. You may not able to have all three at the same time. So this trade-offs gives us two primary models. First is the acid model, ensuring the atomicity, consistency, isolation, and durability used to be the traditional banking and transactional systems. The second is the base model, which is basically available, soft state, and eventual consistency, which is what powers the massive platforms like YouTube, Facebook, where availability is at the top priority. Now, for one of the most important distinctions in the data architecture is OLTP versus OLAP. OLTP stands for Online Transaction Processing. These are the systems that run daily business operation. They are designed for high volume of fast, simple transaction. Think inserts, update, deletes. Perfect examples include e-commerce, bank transfers, and inventory tracking. These systems like Oracle or DB2 are typically row-oriented and support massive concurrent transaction. Let's start with the story. Meet Jane, the owner of a new online coffee shop. When a customer buys a bag of coffee, her website database need to be one thing very fast, right? It has to be very fast. Record the single sale. Customer A bought a product B at a price C at the time D. This is the transaction. This type of system is called OLTP, Online Transaction Processing. Think of it like a cashier at a grocery store. It is designed for speed and efficiency for one customer at a time. It consistently brings written and updated. Its main job is to run the business. But soon, Jan has a bigger question. What's my most popular coffee bean in the winter months among the customers from California? Trying to answer this on a speedy OLTP system would be like asking the cashier to stop working and count everything in the stores of California. It would grind the whole system to halt. Johnny need a different kind of system. One built for asking big and complex questions. Yeah, that's correct. This is OLAP, Online Analytical Processing. OLAP, Online Analytical Processing, think of it as a store manager in the office, in the back office. It's where the analysis sales reports, inventory trends, customer behavior. It's designed for fast reading and analysis the huge amount of data. Its main job is to analyze the businesses. The fundamental split between running the businesses OLTP and analyzing it OLAP is the single most important concept in data architecture. It is the reason everything else we are about to discuss exists. As Jane's business grew, she had data everywhere: sales data, website click data, marketing campaign data. It was a mess. She needed one central, clean, and reliable place for all her analytical data. Yeah, she needed a data warehouse. A data warehouse is a central repository of integrated data from one or more disparate sources. Its purpose is to store historical data to be used for reporting and analysis need, which is OLAP. But how should she build this warehouse? Two master architects emerged with different blueprints: Bill Inmon and Ralph Kimball. Inmon, the top-down architect, Inmon said, let's build one giant, perfectly structured central warehouse first. The central warehouse is highly normalized. From its central hub, you clearly create a central warehouse. Then you create smaller, specialized shops called data marts for each department. It is robust and integrated. The Kimball, bottom-up architect, Kimball said, that's too slow, right? Let's build the department data first based on the business priority and needs. His model uses a user-friendly structure called star schema. The data warehouses become the logical component of these data marts. It's faster to deliver value. So what about ODS? It's an operational data store. It's like a short-term holding data. It stores very concurrent, near real-time data from OLTP system. to feed operational reports without slowing down the main transaction system. The data often processed through an ODS its way to data warehouse. Back to the Giants company story. Then the internet exploded. Suddenly, the Giants company wasn't just dealing with the neat tables of sales. They had customer reviews, social media posts, server logs, even images. This messy, high volume, and fast moving data is called big data. A traditional warehouse which demand clean, structured data couldn't handle this. The solutions to it? Yes, it's a data lake. Data lake, imagine a massive natural lake. You can pour any kind of data into it. It's in a raw native format, structured, semi-structured, or unstructured data. It's cheap, flexible, and perfect for data scientists who want to explore the raw data. Jan's team was torn. Her data scientist loved the flexibility of data lake for machine learning, but her business analyst missed the reliability, speed, governance of the data warehouse. Could they have both? Yes. Enter the data lakehouse. This is a game changer. It is an architecture that combines the low cost, flexible storage of data lake with powerful management features and performance of a data warehouse, like ACID transactions. Technologies like Delta Lake and Apache Iceberg make this possible, bringing the structure and reliability directly to the lake. And this becomes the end of our part 1. In our upcoming part 2, we will dive even deeper into specific architecture patterns, design methodologies, data modeling techniques. Thanks for tuning in and watching so far. We'll see you in the next video.